In the second step of the hypothesis test, we must first declare what test we're going to run. This is a z-test of one mean, and then we need to address the conditions that must be met in order to trust our calculations and conclusion. Normality of the sampling distribution. We already know from our work with sampling distributions that this is accomplished if either the population is normal to begin with or the sample size is at least 30. In the case of the medicine problem, we were told the population is normal. Randomness. For us to avoid bias, we must have a random sample that behaves according to the random fluctuation of normal distribution. In our case, we are told that a random sample of 16 patients suffering from chronic back pain were assigned the new medicine. A sample should never exceed 10% of the population size. If it does, it actually makes the result too accurate, and the standard deviation calculated is not as trustworthy. It's kind of strange, but just always check that the sample is not too big. Equivalent to a sample not exceeding 10% is to establish that the population must be at least 10 times as big as the sample size. In a situation like this problem, just employ common sense that the population of back sufferers must be much larger than 10 times the sample size of 16. Finally, it's wise to mention that a z-test is used when the population standard deviation is known. Later we'll learn how to use a t-test if sigma is not known. In this problem, just write sigma is known, so we're able to use the z-test.